day 2 of adding and subtracting rational expressions. Today we're going to learn how to find rates and simplify compound fractions, which sound kind of scary, but they're not. Okay, so first of all, we're going to learn how to find a rate. I'm sure most of you have had science and learned the DIRT formula. DIRT means distance equals rate times time. Okay, D equals R times T, and we can manipulate this formula any way we want to. If we wanted to solve for T, we would divide by R and get T equals D divided by R, and so forth and so on. Okay, and we can use this, interchangeably back and forth. And that's what we're going to do here. Okay, so Leah drives her car to the mechanic, and then she takes her commuter rail train back to her neighborhood. The average speed for the 10-mile trip is 15 miles per hour faster on the train. Find an expression for Leah's total travel. So, in other words, her total time she traveled there and then back. If she drove 30 miles per hour, then how long did she take? So first of all, we want to find an expression, okay? So you can see right here, the distance was the same regardless. It was a 10-mile trip, both to and from. And I would suggest writing a table like this for a while. It'll kind of help you organize your thoughts. We have our car, we have our commuter rail, we have our distance, rate, and time. And so I always put above on mine, I always have my DRT. So my distance equals rate times time, okay? So if my rate in my car was R, so I'm going, maybe 50 miles an hour, my commuter rail is going to be going 65 miles an hour, so 15 miles an hour faster. I could put an R here and then put R minus 15 here, and that would be fine. Okay, so however you organize it. In this case, we just put the rate for car and then put the commuter rail going 15 miles an hour faster. Okay, so here's where we kind of set up our time, because we don't really know how long they're traveling. So we use our formula here to help us find our time. We take distance divided by rate. So we take our 10 and divide it by R, and that gives us our time in terms of R, okay? We take our distance here, 10 divided by R plus 15 divided by R, and then we get our rate, our time here, distance divided by rate, 10 divided by R plus 15, okay? So our total time there and back, we're going to be adding those two together. Our time for our car, so we have basically our time for our car, plus our time for our commuter rail, R for rail, is going to be 10 over, 10 over R plus 10 over R plus 15. Okay, now that should look familiar. We're adding rational expressions, right? In order to add, we have to have common denominators, right? So I need to multiply this other side over here by R plus 15. And R over R plus 15 in order to find our common denominator, okay? And then I have this R over here, so I need to multiply over here by R over R, okay? So then I will be left with, if I distribute this 10, I'll have this 10R plus 150 over this R plus 15 times R, plus up here I'll have 10R, and then over R plus 15 times R, okay? So my total expression, if I combine these two, are going to be, I'm gonna have 20R and then plus 15 all over my R times R plus 15. I'm just gonna move the R out front there, okay? So this should be my expression for how long my trip was taking, okay? So I'm gonna go over to my next page here as I'm running out of space, okay? So here's my R, oh, yeah, sorry, it should be 150, right? Where did I, backwards. Right here, 15 times 10, I'm sorry, that should be 150, my bad. There we go, okay? All right, so we have this 20R plus 150 divided by R plus 15. So to find out what the actual rate was, I'm gonna put 30 miles per hour in there. So I'm gonna take my 20 times 30 plus 150 divided by my 30 times 30 plus 15. And we'll simplify that, okay? So you have 600 plus 150 divided by 30 times 45. That'll give us our 750 divided by, what is 30 times 45? That is 1350. And then 750 divided by 1350, gonna give us about 0.55. And I'm not sure what that is. It's about 33 minutes, somewhere on there. So approximately 33-minute trip. Okay, and that is how you find a rate. Okay. Oh, I'm sorry, that is my, yeah, 32 minutes. There we go. Okay. So now let's try a different one. If you want to pause this and see how you do it on your own and then come back and see how you do, that would be great. Okay. So we have Juan on the way to work, carpools with a fellow coworker, and then takes the city bus back home in the evening. I have to switch pages here so I can follow what I'm doing here. Take the city bus back in the evening. The average speed of the 20-mile trip, so 20 miles, we know the distance right here. So we're going to put 20 in for our distance, boom, right there. Okay, is 5 miles an hour faster in the carpool. So if my bus has rate R, my carpool is R plus 5. Right, it's 5 miles an hour faster. Okay, write an expression that represents Juan's total travel time. So first of all, this will be, again, my distance divided by rate. So 20 divided by R plus 5. And I'll have 20 divided by R. So we'll do the same thing we did. So our total travel time is going to be adding that time together. So 20 divided by R plus 5 plus our 20 divided by R. And we're going to do the same thing we did. We need to find a common denominator. So we have this R here. So we need to multiply over here by R over R. And we need to multiply this R plus 5 over here. R plus 5 over R plus 5. And I'm going to put that guy in parentheses so we do not forget about him. Okay. So 20 times R will give me 20R over R times R plus 5. Plus, I'll distribute this 20 here through this parentheses. So we'll get 20R plus 100. R, there we go, over R times R plus 5. Now I can simplify and combine like terms on the top. So we have 40R plus 100 all over R times R plus 5. And that is all they're asking here is just the expression. They don't want us to find any kind of total time or anything like that. Okay? And that's how you find a rate. Now we're going to look at a compound fraction. So first of all, what is a compound fraction? It is in the form of a fraction and has one or more fractions in the numerator or the denominator. So you have like a fraction within a fraction. So how can you simplify this compound fraction? Well, it's quite simple. Is what we want to do is find the least common multiple, basically, between my denominators on the top and bottom. Okay, so what is my LCM between x and y? Is just going to be x and y, right? So we multiply them together. Okay, so I should actually go like this because since we don't have any common, it should be an x and a y. Okay, so I'm going to multiply the top up here by xy over, and I'm going to multiply the bottom by xy. Okay, and so this is what ends up happening. I'm going to go 2 times xy, okay, plus, and I have 3 over x, and that's going to be multiplied by xy. So I'm multiplying this whole, I'm distributing this through right here. Okay, so that gets multiplied by xy. That's all divided by 5, and I'll multiply 5 by xy. So now I'm going to be distributing it here as well. Okay, so 5 times xy. Oops, I didn't get that parentheses there. I should be pink. There we go. And then plus, we have one, or no, it's a minus. Gracious. Minus. And I'm going to have my 1 over y. And that gets multiplied by xy. Okay, so this is what ends up happening here. Is first of all, we have up here, we have 2xy. Okay, plus, and then what ends up happening up here is this x here cancels with that x up there. And we end up with just 3y. And you can see how that fraction up on top kind of just goes away. Okay, we still have a fraction on the bottom, so we have 5xy down here. Minus, and then again, this y cancels out with that y right there, and we end up with just an x. So minus x. And there we go. Now we just have a single fraction instead of a bunch of crazy fractions. Okay, that is how you simplify a compound fraction. So let's do one more. Why don't you try to do this and come back and see how you do, and then we'll go from there. All right, so the LCM here, we have basically an x in common, right? So we're just going to multiply by just an x, because that's what the LCM would be, is just x. All right, because we have the x in common. So we're going to multiply this entire top by x and this entire bottom by x. So this will give us a 2 times x, okay, minus a 1 over x times x. And then we're going to do the bottom, x times x again. Okay, so I'm distributing again this x on the top and this x on the bottom. Okay, parentheses there. And this will be plus 2 over x times my x. Okay, so these end up canceling here and these end up canceling here. So all we have left with now on the top is going to be a 2x minus 1. So that's still a 1 on there. Don't forget that 1. And then we have x squared on the bottom plus 2. And there we go. All simplified. Okay. Okay, so this is a little bit of a tougher one. So I wanted to give you one of these harder ones to kind of look at. So what we have here, first of all, is we have a common an LCM. We have the x's in common over here. So if we have our LCM, we're going to create, we have an x. And then we also have this x minus 1 that we need to include. So x times x minus 1. That will be our LCM. Okay, so we're going to multiply this entire thing up here by our x and then times our x minus 1. Okay, and we're going to do that on top and bottom, of course. Okay, so we're going to take our x times our x minus 1, top and bottom. Okay, now you don't need to write out, you know, multiplying by every term every single time. Okay, you can kind of just know when I multiply this by this guy, my x's will be canceling out right here. Okay, and so what I can kind of do is I know that this is going to be canceling out with that guy right there. And so what I'll have left is a 1 times x minus 1. Okay, minus, and then for the when I distribute this guy to this over here, these little x's right here, and I'm going to use a different color, maybe a red right here. These guys will cancel with that guy, leaving me with just a 1 times x. So I just have a 1. Oops, let me make that a little black right here. 1 times my x. Okay, and that's oh, that should be pink. Sorry about that. 1 times x. Okay. Now if we look on the bottom over here, we're going to do the same thing. If we take this 1 times that, there's no denominator to cancel out with that. So we're just going to have just 1 times, and it's just going to be left with x and then times x minus 1 right here. And that should be a black one. So minus, and then this one, again, if we're going to cancel this guy with the x right here, we'll be left with this x minus 1. So 1 times x minus 1. So we have just this 1. Whoops, 1 times, and then my x minus 1 right here. Okay. Now, if we simplify all those, this 1 times x minus 1 is just going to be x minus 1. Get my black color back here. X minus 1 minus x over, and I'm going to multiply these through. So x squared minus x, and then multiply those through, minus x, and then plus 1. Okay. So I'm going to bring this up here. These will just cancel out here, this positive x and negative x. That leaves me with just a negative 1 up here on top. Over, and then I have x squared minus 2x plus 1. And we are all simplified. Okay, so that's kind of a tricky one, right? So you just kind of have to know which ones are going to cancel out and what you have left to multiply on the top. All right? Okay. So you have a summary right here of all of our concepts on how to simplify your numbers and also how to add rational functions together, getting a common denominator. You guys have a worksheet this time. Oh, it says Excel. It's a worksheet. That lies. It's going to be a worksheet for you this time. And make sure you show all of your work on there. And then I will see you all next week. Have a fabulous weekend, and I'll talk to you later. Bye-bye.